Welcome back to the sixth week. This week we are going to start with elasticity. We will learn different kind of elasticities. So we are going to start with this concept elasticity, which is quite prevalent in physics, and then we will come to economics. So let us take a rubber that is used to tie things. Ideally I should have cut it at one place, but I don't have scissor. So just take it like, consider that it is one string, and when I apply force at both end, the length of this rubber changes, it increases. So if there is a material that we take and we apply force at both end and there is a great change in length, we say that material or this item is elastic. If we apply a lot of force and still there is no change in length, then we say no, this item is not elastic. So elasticity is coming from physics, and it has to do with change in length. Delta, this indicates change, and L indicates length. And when this change is happening, when we apply a change in force, we apply a force, so that's why it's a change, and then its impact on change in length, that's what we are talking about. And if it is great, if it's significant, we say item is elastic. But there is a problem with this definition. How should we measure L? Should we measure it in centimeter? Should we measure it in meter? How about force? Should we measure it in kilogram per meter square or gram per centimeter square? So there are problems. So what we do, rather than dealing with units, just make it unitless. And how can we do that? We can talk about proportional change in length when a proportional change in force is applied, and that's what is called elasticity of material. But we are not studying physics, we are studying economics, and that too managerial economics. We do not have length, we do not have force. What do we have? We have quantity on both sides of the market, on the demand side, on the supply side. And what is the force that affects the quantity? That force is price. Price affects the quantity. Income affects the quantity. Even advertisement affects quantity. So we are going to study different kind of proportional change in quantity, when there is a proportional change in price, when there is a proportional change in income, and when there is a proportional change in advertisement expenditure. So all these we are going to study in elasticity in economics. So what we are basically interested in, there is an entity delta Q, or we should say there is an entity Q which indicates quantity, and then there is a change in quantity, that is delta Q, and then there is a proportional change in quantity. This is proportional change in quantity, and it is coming because proportional change in price, or proportional change in income, or proportional change in ad expenditure. Okay. So that's one way to look at it. Another way, this quantity can be quantity demanded or quantity supplied. This price can be own price or price of some other item. This can be own income. This can be the expenditure incurred by your competitor or by you. So there are so many different variation of elasticity one can talk about it. Just symbolically we will pay extra attention to price elasticity of demand. This is a way to understand all these things. And when we are saying price, we don't mention anything. It's implicit that we are talking about own price elasticity of demand. So price of an item changes, and because of that, quantity demanded of that item changes in the market, and that's what we are going to study. So what is price elasticity of demand? This is typically denoted by epsilon, and then here delta Q by Q is a proportional change in quantity demanded demanded. If you want to make sure that it is related to demand, you can put D superscript or subscript, and then delta B P by P, where P is the price of per unit item under consideration. So one more thing you should understand, that when P increases, Q decreases. So if delta P is positive, delta Q is going to be negative. They are moving in the opposite direction. So in many books, I am not saying everywhere, in many books you will say a sign minus here, just to make this epsilon a positive number. Okay, that's just, that's just making it positive. At many places you will see, in many other definition, we don't put a minus sign, because let us say when we are talking about income, when income goes up, it's possible that quantity demanded may go up or comes down. So there we should not be putting a minus sign, because it will change the meaning. But in demand's case, we know for certain that price and quantity demanded, they move in opposite direction. So putting a negative sign is innocuous, it doesn't create any problem, and that's why we will put a negative sign. Now we can do some manipulation here. We can rewrite it delta QD divided by delta P multiplied by P by Q. That's one way to write. Another way to write, we can say, if the change is very small, change is very small, in other word, we can take a limit here. We can do this rather than writing like this. We can take a limit here. We say take a limit where delta P goes to 0. It means there is a very small change. So this can be written as, this will be equal to minus dQd by dP, rate of change in quantity demanded with its own price multiplied by P by Q. And then it can also be written as another, I will go back to the earlier formulation, because we can get a very nice form, that is QD divided by delta P by P. This is basically equivalent to minus D ln QD divided by D ln P. So all of these are equivalent. Okay, of course this is an approximation of price elasticity when changes are not that small. This is for very small change. So that's what we write as the definition. Let us take some of the examples of demand function and try to calculate price elasticity of demand. So one could be, let us say we have P is equal to 10 by Q, although I am saying demand function, but when I write, I am writing the inverse demand function, and that should be fine, because this immediately can be changed to this. How would it look like? If you draw it, it's equation of a hyperbola, and this is the way it looks like. How can we calculate? In this case, it's a lot easier if you use, over the by doing practice, you have to figure out whether to use this formula or this formula or this formula. It all depends on your practice. Otherwise, it will take slightly longer time. So just by looking at it, I can see that if I take log on both sides, what we get is log 10 minus log P, and if I differentiate log Q with respect to log P, what do we get? Minus D log Q by, or we don't need to put a minus sign here, just first do log P, just taking, this is a fixed number, so when we differentiate it becomes 0, and this will be minus 1, and this can be written as D log Q by D log P with a minus sign is equal to 1. What does it mean? That if P changes by 1%, Q also changes by 1%, and this is approximation. because remember the formula that we are using is for very, very small change. So it's possible 1% is a large change. So you will change the, you will take the number, you may get slightly different result, that is fine. But if for very, very small change, this is what would be true, and this is a particular case. We will talk about it once again. We will say whether it is elastic or inelastic, because we need to have cutoff to say whether the behavior of quantity demanded or behavior of the demand function is elastic in nature or inelastic in nature. Similarly, that you can see another one where you can take P is equal to A minus BQ. Of course, what would be the case? From here, you can do dP by dQ, which is equal to minus B. And now we know the elasticity is minus dQ by dP multiplied by P multiplied by divided by Q, and this is minus, and because if you take this, which is inverse of this is going to be minus 1 by B. So this will get cancelled, multiplied by P, which is nothing but A minus BQ divided by Q. So it is A minus BQ divided by BQ. So if we draw, how would it look like? This demand curves look like a straight line which goes like this. Here is Q, here is P, and at P is equal to 0, it is A by B, and at Q is equal to 0, it is A here. That's the way the line looks like. So if you want to calculate, you will see that at this point where P is equal to 0, P is equal to 0 means the numerator is 0 at, at A by B comma 0, elasticity is coming out to be equal to 0. And at 0 comma A, which happens to, A is the reservation price, the way we have figured out. If you calculate this, epsilon is going to be infinity. Why it is going to be infinity? Because this is a positive number, slope is same everywhere. P is positive, that is equal to A, Q is equal to 0. So something is divided by 0, you get infinity. So what we are seeing that on this demand curve, elasticity is varying at this point, it's infinity to 0. By the way, if we had not put this minus sign, then our result would have been here minus infinity. That's what you will see in many books. So in this particular demand curve, elasticity is varying everywhere. In fact, I can say, I am not showing it to you, you can calculate that it's gradually decreasing in this direction if we use this negative definition. As opposed to this, here it's everywhere, price elasticity of demand is everywhere, it is same. So we can say that it is constant price elasticity of demand. Everywhere it is equal to 1. So that's characteristics of this kind of demand function. Here we get the characteristics of different kind of demand function. Great. So far we have been calculating point elasticity. What do I mean by point elasticity? If we have demand function like this, we are taking a point and we are seeing how much is the slope, because in definition we have this is the slope or inverse of the slope, because the way we are drawing here, but nevertheless it is a slope. And then we are seeing that how much is P, let us say P naught, and how much is Q naught. So we are taking a slope at Q naught comma P naught, multiplying it by P naught divided by Q naught. So we are calculating basically the point elasticity. Even in this case, it so happens that point elasticity is same everywhere. This is the way we are calculating. Many times in the market we do not have access to the whole curve. We do market survey and we get something like this. For example, that if price is 10, the quantity demanded comes out to be, for example, let us say 12, and when price goes up to, let us say, 15, the quantity demanded becomes equal to 10. So we have access to these 2 points. We do not have access to the whole curve. So we have difficulty calculating the slope, because the way we have formulated, we need the slope. But if you remember, the earlier definition of elasticity is delta Q by delta P multiplied by P by Q. Now there is a problem, so delta Q is very easy. How much is the delta Q? Delta Q is of from 12 to 10. So delta Q is decreasing. So minus 2. Delta P is from 10 to 15, 5. So this is fine. That we are able to figure out. Now which P should we use? Should we use 10? Should we use 15? Or should we use a number between 10 and 15, which is 12.5 or so? Similarly, so here we can use 10 or 15 or 12.5 divided by how much should be the Q? Should it be 10 or 12 or 11, which is just in the middle? So there are 3 things you can figure out. You can say, you can take the initial number. So if you are taking P is equal to 10, then you take Q is equal to 12. And then your solution is going to be 2 by 5 multiplied by 10 by 12. So this is 6, 2, and which is coming out to be 1 by 3rd. Other possibility is that your slope remains the same, but now you take the final number 15 here and 10 here. So it is 15 and 10. So 3 and here 5. So 3 by 5, different from the original number, you are getting different value. And next is 2 by 5 multiplied by 12.5 divided by 11. So this is 2.5 and this comes out to be 5 by 11. So you are getting 3 different numbers. So one, you can be alarmed by it, that why are we getting 3 different numbers. But another take could be that we do not have access to complete demand curve, and their approximation, they give us rough idea about how much is the price elasticity of demand in that zone. So we can follow a convention. So let us follow this convention, the mid value that we can take. Whenever you are calculating the arc elasticity, you should be taking the mid price value, and then the formulation could be that minus delta Q by delta P, and this is P1 plus P2 by 2 divided by Q1 plus Q2 by 2, or instead of saying P1 and P2, you can say P1 initial, P final, Q1 initial, Q final, and this will get cancelled. So delta Q minus delta Q by Q1 plus Q2 multiplied by P1 plus P2 divided by delta P. But that's just a matter of convention. Some books will follow the other definition, that's also fine. But what I am trying to say, that many a times we do not have access to complete data, but we still want to get some result, and their arc elasticity is very, very useful. Great. So we figured out how to calculate price elasticity of demand. And we can say the greater the number that we are obtaining for epsilon, greater is the proportional change in quantity demanded for the same proportional change in price. But then there should be a cutoff above which we said that, oh, if changes are greater than this particular level, then the demand is elastic, and if it is lower than that level, then it is inelastic. So one natural candidate is 1 as a cutoff. What does it mean? Let us say if this is 1, it means divided by delta P by P. By the way, I didn't tell you earlier, but you can also see this also can be written as this multiplied by 100 and delta P multiplied by 100. So this can be in the percentage term. Here you have in the proportional term, here it is in the percentage term. So we can say if it is 1, what does it mean? That if price goes up by 1%, quantity changes by 1%. So 1 can be cut off if the change is greater than 1. Let us say, for example, 5. What does it mean? For 1% change in price, 5% change in quantity. So we can call it elastic. So if our cutoff is 1, we can say if elasticity, that can be written by E or epsilon, greater than 1, we say elastic. If E or epsilon less than 1, we say inelastic. What does it mean? Let us say if price changes by 1% and quantity changes by, let us say, 0.1%. So there is no great change in quantity and therefore it is inelastic. It's like you put lot of force but length of the string doesn't change much, and therefore you will say that material is inelastic. Okay, similar thing like that. But there is one other way to look at it. Let us look at that other way. Let us look at the revenue a firm makes. So firm has no control over the quantity demanded at particular price by consumer, because quantity demanded is coming from consumer side, how much of money they have, what kind of things they like. So firm has no control over on the demand side. So what would be the revenue that a firm makes? Let us say P multiplied by Q. And think for a moment, it's slightly advanced, but think for a moment that it's not a like perfectly competitive market that the firm takes price as given. It has control over the price, but you can think of a situation like a monopoly. This is the only firm that's selling this particular item. It may not necessarily be monopoly, we will talk about it later on, but it's good idea to understand as of now that let us say that it is like monopoly. So if firm prices its product too high, the quantity demanded is going to be very, very low. If firm prices its product low, that quantity demanded is going to be very, very high. So P is a function of Q, or in other way we can say Q is a function of P. They are not independent of one another. So we can say total revenue is P multiplied by Q. And let us say in this case, how much should be the price? Let us say we are not worrying about cost, we are doing very specific calculation. It's not about maximizing cost or maximizing total profit. It's not about minimizing the cost. Let us say, bear with me for a moment, and let us say it is about maximizing the revenue. So if you want to maximize revenue, how to figure out how much should be the price? You can also differentiate with respect to Q, because Q and P are linked with one another. What will you get? You will get P plus Q dP by dQ. That's what you will get. P out 1 plus Q by P dP by dQ. This may look familiar. It's related to price elasticity of demand. So we can rewrite it 1 plus, of course P is outside, 1 divided by dQ by dP multiplied by P by Q. And this is negative of price elasticity of demand. So we can write it this as, now what does it mean? If epsilon, and clearly that cutoff point is 1 equal to 1 by epsilon, or epsilon is equal to 1, that should be the cutoff. So let us say what happens if epsilon is equal to 1. It means the rate of change in total revenue with respect to Q is equal to 0, because 1 by epsilon is going to be 1, 1 will get cancelled, so no change. If epsilon is greater than 1, what do we get? Let us write P1 minus 1 by epsilon. This is greater than 1. It means 1 by epsilon is less than 1. And therefore, this whole thing is positive. So, this is positive. So, when you increase Q or increase Q is related to decreasing P. So, if you decrease the price, total revenue goes up. And this is very, very important point. What's happening? That you are increasing price by 1%. It means quantity is changing by more than 1%, and they are moving in the opposite direction. So, little change in price is bringing a big change in quantity, and therefore TR is falling. Remember, here we are talking about price change, here we are talking about quantity change. So, we are talking in the opposite direction. If you want to interpret this, you can say that decrease price by 1%, quantity goes up by more than 1%. So, it compensates and total revenue goes up. So, decreasing price increases the total revenue. And exactly, let me change the color so that here only I can write epsilon is less than 1. What will happen here? 1 by epsilon is greater than 1, and therefore 1 minus something greater than 1 will get you a negative number, and so it means change in revenue with respect to Q is going to be less than 0. What it means is that if Q goes up or P comes down, total revenue falls. So, it is a bad idea to decrease price here if you are operating in inelastic zone. It is bad idea to increase price if you are operating in the elastic zone. So, now we have a cutoff, and we will talk about these things once again. We have a cutoff, epsilon greater than 1, equal to 1, less than 1. This is called elastic zone. This is called unit elastic, and it is not a zone because that's just one value at which it's happening, and this is inelastic. We can see all these things using graph also. So, let us say we have P is equal to A minus BQ, that we have already seen. How would it look like? If we want to talk about total revenue is P multiplied by Q. In other word, A minus BQ multiplied by Q. This is a quadratic equation. At 2 points it attains 0, at Q is equal to 0 and at Q equal to A by B, and it attains maximum when Q is equal to A by 2B. So, of course, this is an equation of parabola. You can go back to coordinate geometry, or you can just draw by giving different numbers. So, it's going to be, let us write first, let us draw the A by B, and this line is A minus BQ. P is equal to A minus BQ, and we can extend it further, and we can have it like this here, and then we can do is the total revenue. This is total revenue with respect to Q, and this is A by 2B, and this is the point A by 2B where it attains maximum. So, what we discussed earlier, we can see it here how it is happening for the straight line. You are increasing Q in this direction, you are increasing P in the opposite direction. P is minimum here, P is, look at this graph here, P is 0 here. As you move in this direction, P is increasing. So, P is increasing in this direction and Q is increasing in the opposite direction. So, what we see here is in this zone, let us say in this zone, as q, let us say from 0 to a by 2b, as q increases, and clearly as q is increasing, or we can say p decreases, total revenue is increasing. It's going up like this. So decreasing the p, increasing the total revenue, and therefore we can say this zone is elastic zone. Which zone? Let us say this zone is elastic zone. How about a by 2b? Here exactly it is unit elastic. And then the third zone is the remaining zone, which is this zone. What is happening in this zone? As q is increasing, let us say from a to 2b to a by b, as q increases or p decreases, total revenue is decreasing. So this is inelastic zone. This zone is, we can say, inelastic zone. Let me repeat once again, and it's very important to understand why total revenue is falling. You are decreasing the price, let us say by 1%. Q is not decreasing by, Q is not increasing by more than 1%. In fact, Q is increasing by less than 1%. And total revenue is P multiplied by Q. If this is decreasing, let's say this is decreasing, Q has to increase by significant proportion to compensate. That's not is happening, and therefore in this place it is inelastic. As opposed to that, from 0 to AB, if you are decreasing the price by 1%, quantity is increasing by more than 1%, and therefore total revenue is going up. So this also gives us a ground to say that 1 should be the cutoff. And once we figure out we are not going to do this test all the time, we take 1 as the cutoff to say that in which zone we have elastic demand function, in which zone we have inelastic demand function, and this is very important to understand. Great. Now let us look at factors that affect the price elasticity of demand, and some of these factors are, the first one is related to substitution. Let me give you an example. That we all eat salt as condiment. We, to make our food salty, we use salt. Do we have a substitute available for salt? Perhaps not. There are many other condiments, many other herbs, but nothing can replace salt, and therefore it lacks a substitute good. And therefore one can say that price elasticity of demand is going to be fairly inelastic for salt. I will come to the salt example once again because it plays a role somewhere else also. Like for example, let us say it's coriander, and I am talking about food. Coriander, which is also called cilantro or dhania in Hindi, it has other substitute. Perhaps mint or pudina can be used as a substitute to make chutney or to flavor food. So therefore its demand is going to be relatively elastic, because if price of coriander goes up, you will like to use less of it because substitutes are available. So substitution is also an important criteria to determine the price elasticity of demand. I said that I would come back to the salt. In the second example itself, I will come to the to salt, and second is expenditure as percentage of budget. If we are spending very tiny percentage of budget on one item and its price goes up, we are not that bothered. For example, our expenditure on salt is very little. So even if the price of salt goes up, we are using tiny fraction of salt, tiny fraction of our income on salt, so it would hardly matter. But if we want to purchase a big ticket item which is expensive, it takes significant proportion of our income, and if its price is changing, we have to be doubly sure whether we really want that item or not. So expenditure as a percentage of budget on that particular item plays very important role. Third factor is of time. The time is a very good healer, we say, but jokes aside, think about time. Let us say the price of petrol goes up and you use your car to commute to go to your office. Will you decrease your consumption in immediately? You would not, because you do not have other means to go to go to your office. But in long run, perhaps you will change your ways. Perhaps you will start taking metro or bus, or perhaps you will buy a car which consumes less oil, and therefore your consumption of oil will go down because of this price increase in future. So whether we are looking at short run or we are looking at long run, the price elasticity of course depends on this time duration. Next is income effect, and we have already discussed the income effect. Remember, what is income effect comes into play in two instances. One, if your income goes up or the price of an item changes. In fact, even in the first one, why just income goes up? Even income comes down, in other way income changes, or price of that item changes. When price of the item changes, we divided the effect into two parts. One is substitution effect and second is income effect. So here also income effect plays a role. Remember, if a good is a normal good, then income effect reinforces the substitution effect. They work in the same direction. So normal good will have higher price elasticity of demand, because both income effect and substitution effect are working in the same direction. But if we are talking about inferior good, then the story is different. Income effect is trying to undermine the substitution effect, and therefore change in quantity demanded is going to be different. So inferior good will have lower price elasticity of demand. The next factor that we should look at is definition of the good. If we are talking about food, then we need food to survive. Perhaps our price elasticity of demand is going to be lower. But when we are talking about, let us say, mango versus apple, if price of mango goes up, then we can shift to apple or some other fruit. So the way we are defining the good also determines the price elasticity of demand. Okay, if you know food, demand for food is going to be relatively inelastic than demand for fruit, and demand for fruit is going to be relatively inelastic as demand of mango or demand of apple. So that's the way definition of the particular good matters. And there are many other factors, some I have decided to illustrate here. Another factor that I want to talk about is addiction. Like if you are addicted to a particular item, like if someone is smoking, and mind you, smoking is injurious to health, I want to emphasize once again. But if you are a smoker and price of cigarette goes up, you will not decrease your consumption. The reason is very simple: you are addicted to that good and you would be willing to pay for that good even if it costs higher. So addiction also plays very important role in determining the price elasticity of demand. Now let us look at price elasticity of demand for some of the items. Unfortunately, the data that I have taken is from Wikipedia and mostly it's for US. Okay, one could try to calculate it in India also. In fact, we are going to talk about techniques, but not in that much detail, practical techniques as well as theoretical techniques, how the price elasticity of demand is determined in the market. But this data is from US. Wikipedia was using slightly different definition. Let me tell you, their definition was they didn't had the minus sign, they had this definition. So I have changed it accordingly because I have put a minus sign. So their numbers are in negative, my numbers are not here in negative, but this data is coming from Wikipedia and here is the source, you can check it. They have price elasticity of demand for many other items. Cigarette 0.3 to 0.6 for general public, and for youth it's 0.6 to 0.7. You will see that for youth it's relatively more elastic. So youth get more affected if there is a price change. Alcoholic beverage, again you see that for beer it's relatively inelastic, wine it is unit elastic, and for hard liquor it is relatively elastic. So hard liquor people are willing to shift if the cost goes up. Airline travel, it's fairly inelastic. What does it mean? The price, if you increase the price, total revenue goes up in case of first class travel. For discounted it is 0.9, and this is remarkable. For pleasure traveler it's very elastic, and we will say that this particular information plays very important role when we talk about price discrimination in future chapter. While it is 0.4 for car fuel, again these are the different values. If you look at medicine and if you have insurance, in US many people have insurance, it's 0.31, it is inelastic. But look at the elasticity for pediatric visit, it's all very near to 0. So even if the price goes up, people are willing to spend money for their kids medicine. So that's fairly inelastic, it's hardly gets affected by the price. So one thing one can think of that, of course if there is only one company selling a particular product, they have excessive power over market, and we are going to see it in the future when we study the chapter on monopoly, that it's very important, and such market must be regulated because monopolists can charge very high fee. And this is for rice. Okay, this is for rice. You will see two things like Bangladesh, China, these are rice eating countries. So it is inelastic, but Japan is also rice eating country. So they have more money, so it is more inelastic. Okay, so that's the data that we have. I just wanted to give you feel. These numbers are of course important, way more important than theoretical knowledge, but there is nothing that I can teach you with these numbers. This is calculated by collecting the data from the market, putting it in the formula and getting the value. That's a very different kind of technique. We are not emphasizing on that technique in this course, but anyway I felt that you should understand these values. Let us now talk about what we call cross elasticity of demand. If I want to write it in detail, which no one writes, but we can say this is cross price elasticity of demand. What does it mean, cross? Here in the earlier case, when we were talking about price elasticity, we didn't use the word own. We were using the own changes in the own price to see its impact on changes in quantity demanded. Here we are going to use cross price, means price of some other item. So here we can say we want to calculate price elasticity, cross price elasticity of item 1, and we want to see how it gets affected by change in price of item 2. So let us say we can write it here, delta Q1 by Q1 divided by delta P2 by P2. Why I am putting a subscript, 2 subscript here 1 and 2? Just to indicate that we want to understand proportional change in quantity of one item vis-a-vis proportional change in price of other item, not for the, so that's what we are talking about. And how about a minus sign? That we don't want to put. The reason is very simple, that for some it's going to be a negative number, for some it's going to be a positive number. How? Let me talk about the two kind of goods that we had studied. One good was substitute good. substitute good, and the second was complementary good. How are they get affected? So if price of good 2 goes up, you will demand less of good 2 and you will demand more of good 1 if good 1 is substitute of good 2. So in this case the number is going to be come out to be positive. And when it is a complementary good like bread and butter, if price of butter goes up, your demand for bread will also come down. So here it's going to be negative, and therefore we don't put a sign here because sign has a particular meaning, and that's what cross elasticity of demand is. Let us move further. Why, we figured out that demand for a particular item depends on its own price, it depends on other items price, and it also depends on income, and it can depend on many other parameters. The formulation that we used, a simple formulation, there we saw it depends on P1, it depends on P2, it depends on I. Just to remind you, when we used P1, we said price elasticity of demand. The hidden word was own. We were not writing own. Here we had cross and we were not writing price. So cross elasticity of demand. And here now we have income elasticity of demand. What is income elasticity of demand? We have already figured out. We can write here I as subscript. This symbol is for elasticity of demand, and I as subscript to indicate proportional change in quantity demanded with proportional change in income. So here we are measuring with respect to income. How about putting minus or minus sign here? Again, we don't want to put it because it's very much possible that income goes up, quantity demanded goes up, or income goes up, quantity demanded comes down. We have already discussed this normal good as well as inferior good. So in case of normal good, delta I is positive, delta Q is positive, and therefore in case of normal good we can say that income elasticity of demand is greater than 0. In case of inferior good, if income goes up, quantity demanded comes down, and therefore we can say here income elasticity of demand is negative. So again, therefore we do not put a sign here to understand what is happening. In fact, sign gives us some meaning, so we leave it as it is, and that's the convention we would follow. In this slide, we are going to look at income elasticity estimate of selected product. Again, I have taken this data from Wikipedia. For automobile, if there is 1% increase in your income, there is 2.98% increase in number of automobile bought or sold. Of course, here we are clubbing all automobile. Again, data is taken from Wikipedia and perhaps it's from US. And here, of course, it's about market demand, not about individual demand. Similarly, for base metal, it's 0.9. For copper, it's 1%. For book, again, it is elastic. When your income goes up, you read more books. Energy, your requirement is not that high for energy. So income goes up, it's relatively inelastic. And here is a margarine, which is considered now an inferior product than butter. So if your income goes up, rather than buying more margarine, you will like to buy more butter. And therefore margarine is an inferior good, and therefore you are getting a negative number. Similarly, public transport, when you have more money, it's more likely you will shift to your own transport rather than taking public transport, and therefore it is an inferior good and you have a negative number. Restaurant meals, again As you have more income, it's more likely that you would go to the restaurant, and therefore it is a positive number and greater than 1. And similarly for tobacco, you are already addicted. Even if your income goes up, your consumption doesn't depend on that much on income. You are addicted anyway, you are consuming. So that's rough idea about income elasticity estimate of selected product. Now, now let us look at advertisement elasticity of demand. Just to remind you, the elasticity is a word, is a term that is coming from physics. And we had discussed right at the beginning of this long lecture what elasticity is. Just to remind you, in physics, if we apply a force, there is a change in length of the material. So we say that elasticity is proportional change in length when there is a proportional change in force is applied, and that's what is elasticity. So we borrowed this term and we said that in economics we do not have length, we do not have force. In place of length we have quantity, and so far we have been talking about quantity demanded, but in next slides, further slides, we will say that it could very well be quantity supplied. It's just one has to keep in mind that quantity demanded and quantity supplied, they react differently to a change in own prices and other factors. So that we have to keep in mind. But so in place of length, we have quantity, and in place of force, so far we have seen the own price, we had other goods price, and we have also seen income. Now we are going to talk about another force, that is advertisement. Advertisement also has this ability to change quantity demanded. Just think about our consumption, the item for which we see more advertisement, most of us get swayed by it and we buy more of those items. Typically, advertisement doesn't have a negative relationship with quantity, because if firms, if they know that advertisement is going to lead to a decrease in quantity demanded, they would not go for the advertisement. So typically, as advertisement expenditure goes up, the quantity demanded goes up. So let us take a demand function which depends on several factors. Let us say it is Q1, quantity demanded of good 1, 1000, minus let us say 4P1 plus 2P2 plus 0.08i, and that just I have created this example to illustrate certain point. So very clearly we can see from here, as P1 goes up, Q1 comes down. Okay, so when we are talking about a demand curve, we take P1, we can vary P1, but we take P2, I and A as fixed. But when we are interested in understanding the effect of advertisement, we will take a particular P1, we will take a particular P2, and we will take a particular I, and we will see how Q1 is changing with different A. Okay, but to continue this, we also see here further that as P2 goes up, Q1 also goes up. What does it mean? That good 1 and good 2 are substitutes. As price of good 2 goes up, people shift to buying more of good 1. Similarly, here we can see that as income goes up, Q1 goes up. It means good 1 is a normal good. And now we are back to the advertisement. So how can we write what is the price elasticity, or sorry, advertisement elasticity of demand? We can give here a subscript, and this is going to be change, proportional change in Q1 with a change in advertisement expenditure. And this can be written as, this is in a way a repetition, but just for revision, it's good idea to look at it. And this is very easy to calculate. We see what is the rate of change in Q1 with respect to A, while we keep everything else fixed. it's simply 0.002, and then we can put this term A by Q1. And let us say that we are evaluating at a point where Q1 is equal to 1 and A is equal to 600. So we can plug these values. We will get 0.002 multiplied by 600 divided by 1, and that will come out to be 1.2. And so we can say it is the advertisement elasticity of demand. It is elastic in nature. Okay. Now let us move to a different side of the story. As I was saying earlier, that a change in quantity may not always be from the demand side only, it can also be from the supply side, and that one has to consider. The only difference is that on supply side, the supply function is an upward sloping function. Okay, this is P and this is Q. And remember, the way we are drawing, when we derived the supply function, how did we go about it? We said, let us draw the average variable cost curve. Then let us draw average marginal cost curve. And we figured out that this, or let me change the color, this curve, this black curve, and this part, this is the supply function. Okay, and so supply either is not changing as P is changing. In this part, clearly price elasticity of supply is 0, and in this zone, the as price is changing, supply is changing, so of course it will have some value. And similarly, we can say here that in this case, if this is our supply function, if this is our supply function, so what it means, that how can we get the average cost curve? Just to complete the story, let us say this is the, sorry about it, this is the marginal cost curve. So the average cost curve must be like this is average cost curve, and that's why we are not drawing, but nevertheless it's upward sloping everywhere. So how can we talk about price elasticity of supply? The same formulation, typically we use eta. We can also use epsilon s to indicate that we are talking about supply side. Typically when we say elasticity, what we mean is the consumption side. So whenever we want to use elasticity on supply side, we will very clearly mention that we are talking about supply side, or we will put this eta as the symbol. And so this is proportional change in quantity supplied divided by proportional change in its own price. And then again we can have, and we don't need to put here positive or negative sign. Remember, why did we put negative sign in one of the elasticity cases? Because we wanted positive number. Here, because supply curve is upward sloping, so it is guaranteed that it's going to be positive, and therefore we do not put any sign here. And this can also be written as delta QS divided by delta P, P divided by QS. This can also be written as D ln QS, D ln P. And all these formulations that you have seen. And the technique is the same. The way you could calculate price elasticity of supply is mathematically same as calculating price elasticity of demand. So that's why I would not get into any more details of this. Now let us look at the four extreme cases. We have, let us say we are using epsilon as price elasticity of demand, and eta is price elasticity of supply. And we know the range, it varies from 0 to infinity, and here also it varies from 0 to infinity. So what are the extreme cases? That epsilon is either 0 or infinity. Here is also it is 0 or infinity. So first let us look at the demand side. We are talking about If price elasticity, let us say eta, is everywhere 0, what does it mean? That here is P, here is Q, and this is the way curve will look like. Because if there is a change in price, there is no change in quantity demanded. So that is epsilon 0. How would epsilon is equal to infinity looks like? And of course, I am abusing the notation. It will never be equal to infinity, but you understand what I am saying. And in this case, it's going to be horizontal. P and Q, this is a horizontal curve. Even if a tiny change in price will lead to humongous change in quantity demanded, it will become immediately equal to 0. So that you should be well aware of. Now let us get into eta, and here again it is same, exactly the same curve that you will get when it is 0. It's a vertical curve, and when it is infinity, you know, it looks like this. So what we can say, how would the supply function look like? Let me use a different color, black. The supply function, let us say from 0, you know, it's, or we can say, like, we can go in the opposite direction and say, so from infinity, you know, if it's decreasing, it's becoming like this, it's becoming like this, and ultimately it becomes like this. This is the way supply function is varying. How about the demand function? Demand function, we can say, is varying something like this, but the extreme cases, they look very similar, even though one is downward sloping and one is upward sloping. So here it is like this, and then this, and then this, and ultimately it becomes like this. So that you should be aware. Okay, so extreme cases look exactly the same, but otherwise they are very different. One is a downward sloping, another is upward sloping. So before we close this video, let us also look at factors affecting price elasticity of supply. First is availability of factor of production. Let us say price of a good is increasing in the market, has a potential to increase, but you need many raw materials to manufacture that product. And unfortunately, one raw material is not available. What would happen? If that raw material is not available, then you would not able to produce it. So even at higher price, you would not be able to increase the supply, so your supply would remain relatively elastic if factor of production is a concern. Next is production process and capacity, which is also related to time. If production process is really long, let us say if there is a sudden increase in price, you may not be able to respond to that increasing demand in the market. You won't be able to increase your supply, and therefore supply would remain inelastic. Same with capacity. You have reached to up your capacity, even the price of that good has potential to go up, you won't be able to supply more. And all these things will be affecting the price elasticity of supply. Now let us come to this inventories. If price is going up, of course you would reduce your inventory and sell the product in the market by increasing supply. If you have inventory, your supply is relatively elastic. If you do not have inventory, your supply is relatively inelastic. So I think we had enough of a discussion on elasticity. You should be very clear about it. This is a very practical measure. Most firms, most manager, they use this particular measure. Next week we will also talk about figuring out, you know, these some of these elasticity in a practical manner in a market or in a society. Okay, but as of now, that's it for elasticity. See you in the next video.